And here we go. So welcome everybody to math. It's February 1st, 2021. We're going to do lesson 13 today, statements of order in the real world. So when we talk about order, we're talking about least to greatest, greatest to least. And we're talking about real world examples of when you would use this for math. Opening exercise. A radio disc jockey reports that the temperature outside his studio has changed 10 degrees since he came on the air. What do you think that means when he says the temperature has changed 10 degrees since he came on the air? Aiden, what do you think?
So either the temperature went up 10 degrees or it went down 10 degrees.
Exactly. So it's either a positive 10 if it went up 10 degrees or a negative 10 if it dropped 10 degrees. Good job. Here's another real life example of a bank account. There's a $25 credit and a $25 charge. They seem to be similar, but they're actually quite different. What is similar about them? What is similar? Riddick? They're both 25s, so they have, watch this, the same magnitude. Remember magnitude? Is how far away it is from zero. How much does it affect your bank account? Those two things affect the bank account in exactly the same amount. It's either a plus 25 or a minus 25. One's not bigger than the other. So that's how they're the same. How are they different? How are they different? A $25 credit and a $25 charge. Olivia. Yep, a credit would be a positive $25 and a charge would be a negative $25. So that's how they're different. The rest of the assignment today is going to look very much like exercise 1. We're going to do this exact exercise 4 or 5 times for practice. And there is one in the problem set also. So let's take a look at exercise 1. Scientists are studying temperatures and weather patterns in the northern hemisphere. They recorded temperatures in degrees Celsius in the table below, as reported in emails from various participants. Represent, here's where the directions begin. Represent each reported temperature using a rational number. Then order them from least to greatest. Riddick.
I can't even see the board.
I'm sorry?
I can't see the board. I can't see it. The light are not.
Can you dim the lights then?
Yeah.
All right, so here's the question, guys.
Right.
8 below 0. No, Riddick, it's fine. 8 below 0. What integer would I write? It's below 0, Anna. Negative 8. This is a positive 12. Negative 4. What about 13 degrees below 0? Blake, what would that one be? And there's a 0. How about 2 above 0? Camden. Positive 2. 6 below 0. Katie? And then there's a negative 5. So we did the integers. Now they want them in order from least to greatest. Now remember, least is going to be the farthest on the left on a number line. Is it going to be the negatives first or the positives if we're starting with the least?
Negative.
So let's look at all the negatives and figure out of these negatives, which one will be farthest to the left on your number line. And you have a number line on your table that has these exact numbers on it. So there's a negative. There's a whole bunch of negative numbers. I see 5 of them. Which one of these is farthest to the left, Felicity?
13.
So negative 13 is going to be first, and then I'm going to cross it out. After 13, let's see what we have left. What do you think would come next, Tyler? Out of those 4. Perfect. Bunch of geniuses in here again today. Now I've got these 4 left. What would be next, Brock?
-6.
Absolutely correct. Now I've got -5 and -4. Braden, which one first?
-5.
Yep. And then -4 is the only other negative number. So now I've got left 0, 12, and 2. What would I put down first? Alexis?
0.
And then what after that? Olivia?
2.
And then that leaves 12 at the end. And remember, least to greatest. Least starts with an L. The arrow points to the left for less than. Less than, less than. That's an inequality statement. All the numbers are in order from least to greatest. And less than points to the left because it's left. Less than, least. That's how you remember which way the arrow points, to the left. All right. Got 3 more very similar stories. Here we got a bank account story. Each transaction, represent each transaction as a rational number. So we're going to put the numbers in the boxes. Then we're going to order them from greatest to least this time. A debit of $12.20. What integer would that be?
12.
Positive or negative? It's a debit. I'm taking money out of your account. Negative $12.20. A credit of $4.08. Positive or negative, guys? Positive $4.08. A charge of $1.50. Felicity? You betcha. A withdrawal of $20. Cassidy? Negative $20. A deposit of $5.50. Brock? Deposit.
Positive 5.
Yep. A debit of $3.95. Liam? You bet. And a charge of $3. Lene? Right. Now, greatest to least. So we're going to find the biggest number. Will I start with positives or negatives this time? Catalin? Greatest to least. We're going to start with positives. So let's find the positive numbers. There's only 2 of them. Is that right? So which is the biggest number? 550 is going to be first. And then the only other positive number has to be second, because then we switch over to all the negative numbers. Now, these are not integers because they're not whole numbers. They're actually decimals. So out of these decimals, when we switch over from positive to negative, which one of these numbers would be closest to 0? Because now we're switching over to the other side. Aiden? Negative 150. Now I've got 12, 20, 395, and 3. What would be next in my list? Riddick. Negative $3. Exactly right. I've got these 3 left now. Which one would be next? Riddick? Exactly right. And out of these last 2, Liam, which one would come next? 12 or 20? Yep. Negative $12.20. And that leaves this one at the end. Now, greatest to least means the arrow's not going to point to the left, because that's when we do least to greatest. So it's going to point the other direction, right? These are all greater than signs. During the summer, Madison monitors the water level in her parents' swimming pool to make sure it's not too far above or below normal. The table below shows the numbers she recorded. Order the rational numbers from least to greatest. So Above normal or below normal? Above normal would be positive or negative?
Negative. Oh, positive.
Positive. And below normal would be
Negative.
negative. So 1/2 inch above, 1/4 of an inch above, 1/2 inch below, 1/8 inch above, 1 1/4 inches below, 3/8 below, and 3/4 below. We're going to order them from least to greatest. So we have a little bit of a problem with this one. So let's look at, we got to do negatives first because we're going to go least to greatest. So look at your negative numbers. Tell me what you think the problem's going to be. Brock.
Least to greatest.
Least to greatest is the directions, but why is this one going to be difficult? There's something about these fractions. Look at them. Catalin.
There's a whole number.
Okay, there's a whole number. Anna?
They're not in decimal form.
They're not in decimal form. True. Olivia? All the denominators are different. So when you compare fractions, you can only compare them if you have same denominators. Or we could switch them all to decimals. Which do you prefer? Rock says decimals. How many people want to do decimals? How many people want to do fractions? All right, decimals wins. So this decimal is, what's 1/2?
0.5.
Yep. What's 1/4? You guys have these memorized. These are the ones we said we had to memorize. 1/4. Brock? Who knows what 1/4 is?
25.
0.25. Negative 1/2 is going to be negative 0.5. What about 1/8? Do we know that one? What do you think, Brock?
15. Or
1 divided by 8. Let's see. 1.125. Then negative 1 and 1/4 is going to be negative 1.25. 3/8 is going to be that decimal. And what about 3/4? Anybody remember that one? Aiden?
0.75.
So we got negative, 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 positive, negative, positive. Okay, so least to greatest. Farthest to the left. Where do I start? Riddick?
I got a question.
Sure.
I feel like for those like turning them into decimal, I feel like it's just easier just to count below like 1, like you do 0.5. I feel like you just count like quarters and like cents, like
Right, exactly. Good point, good point. Out of these negative numbers, which one is going to be farthest to the left? Think carefully about that. Olivia pointed out there's only one number that has a whole number with it. Who did? That was Kat? Sorry. Which is farthest to the left, Braden?
Negative 1.5.
Now let's see what I got left. I got this. I got these 3 left. Now I've got tenths, thousandths, and hundredths. So if I change them all to thousandths to make the decimals match, I've got 500, 375, or 750. Which one would come next, Brock?
750.
You bet. I've got these 2 left, 500 or 375. Brock?
500.
Okay, now I've got these positive numbers left, which is 1, 2, 5, 2, 5, and 5. So again, make them all hundredths. 1, 2, 5, 250, or 5. Which is going to be next, Olivia? And I got these two left. What comes next? Aiden?
0.250.
And then last would be this one. And this is least to greatest, so the arrows point to the left. That's probably the hardest one because we switched them all to decimals. You could have switched them all to fractions and had the denominator of 8, change them all to eighths, and it would have worked out the same way. All right, let's look down here. Changes in the weather can be predicted by barometric changes in barometric pressure. Over several weeks, Stephanie recorded changes in barometric pressure seen on her barometer to compare local weather forecasts. Her observations are recorded in the table below. Using the rational numbers, we're going to order them from least to greatest. So there's a rise or a fall. Which one's going to be positive? A rise or a fall? Rock?
Rise.
And fall is going to be negative, so this is going to be a positive. This will be a negative. Now notice we're in hundredths and hundredths, so far we're good. A rise is going to be positive, but that's not in hundredths. How can I make it look like hundredths? You bet. A fall is that. A rise is that. A fall and a fall. Those are all my numbers. I've got 1, 2, 3 negatives. And we're going least to greatest. So out of these three numbers, I've got 3, 9, and 14. Which one would be farthest to the left, Katie? Oh, you're right. Sorry. All right, now 21, 3, 9, or 14. Where do I begin? Olivia? Yep. Next, Alexis. I got these three negatives left. There's one first before that, 14. Then 9. Then 3, right? Now we're on the positive side. I've got 4, 20, and 10. Which comes first, Felicity? Now, 20 and 10, what comes next? Liam?
10.
You bet. And that leaves 20 at the end. And we said least to greatest, so the arrows are going to point to the left. Just like that. Now you're going to get to see my beautiful artwork. Don't judge. I teach math. There's a reason why I don't teach art. But check this out. We're all going to draw. You guys are better than me. A captain of a fishing vessel is standing on the deck at 23 feet above sea level. He holds a rope that's tied to his fishing net, and that fishing net is below him underwater at a depth of 38 feet. Draw a diagram. So I'm not going to use the number line. I'm going to draw the picture. So here is sea level. What number do I put at sea level? 0. Here's my ship. Here's my captain standing on the ship. And in his hand, he's holding a rope. And the rope is going down. And then they said it goes below water to a net. Okay. So it says the fishing vessel, he's on the deck. This is 23 feet above sea level. And the fishing net is where?
The fishing net is 38 feet below.
So what number do I use for 38? Below. Below sea level. What number would that be? Negative 38. So positive 23 is above sea level. There's 0, and there's the fishing net 38 feet below sea level. And the question, I have two questions for you. First of all, is more of the rope above water or below water? Where's most of the rope? Brock?
Below.
Mostly below. It's 38 feet of rope in the water and only 23 above. From this picture, can you tell me how long the rope is? Lene, can you tell how long the rope is? If it goes from here to here. Come on, wake up, girlfriend. Yes, you do. Don't tell me the number. Just tell me, can you figure it out? Is there a way to find it, Dylan? How would you find it? Adding the two lengths. Add the 23 to the 38. The rope is 61 feet long.
Yep.
And most of it is underwater. Yes?
Wouldn't it be 60 because of sea level? Because of 0? Wouldn't it be 60 because of
Unknown caller.
No, because 0, if I added 0 in, it still wouldn't change the number.
No, like just you're adding 1 because you're adding at sea level.
No, no, but I appreciate the question. Okay, we are going to skip this question because I think it's kind of a dumb question. You're going to do this. Tear off the last page, put your name up here. Problem set. Here's what we got. Negative air pressure created by an air pump makes a vacuum cleaner work. So when you vacuum something, you're actually taking out air. Would that be a positive or negative, a vacuum? It's a negative airflow. All right? So here we have pressure, vacuum, 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 pressure, pressure. Pressure, PSI 25 is going to be a positive 25. And a vacuum of 13 would be negative 13. Does that make sense? So you're going to fill in the chart. You're going to write the rational numbers from least to greatest. And then I want you to go down, because before you start that, we're going to go down here and draw another picture. Okay. The fuel gauge in Nick's car says he has 26 miles to go until his tank is empty. He passed a fuel station 19 miles ago, and a sign says there's a town 8 miles ahead. If he takes a chance and drives ahead to the town and there is no gas station there, does he have enough fuel to get back to the last gas station? I want to draw a picture with you before you answer these questions. So, draw a picture of your car. There's my car. And it says back here, 19 miles back there was a gas station. And ahead of me, there's a town 8 miles away. Now he can only travel 26 more miles before he runs out of gas. So here's the question. If he drives to this town and there's no gas station, does he have enough gas to get back to this gas station? So please finish number 1. It says put the numbers in, and then you can use this space up here to do your least to greatest. and then answer the question back here. If there isn't a gas station, does he have enough gas? All right? Go. You're going to turn this into me when you finish, and then you can have free time after that.